Okay, so this is a second video going through the complete problem. I've got my complete problem written here. It's about a dog food company. So I need to go through and I need to work out how I'm going to do all of this sort of stuff. So this is a little bit different in the structure. So I'm doing this one as a supplement to the one that you've already got, and it will also be posted into your Google Classroom today. So the first bit is we need at least 18, whatever it's called, an international unit of vitamin A, and there are 3 parts in ingredient 1 and 1 part in ingredient 2. I need 15 of vitamin B, and there are 2 parts in ingredient 1 and 1 part in ingredient 2. I need 18 of vitamin C, and there's 1 part of vitamin C in ingredient 1 and 2 parts in ingredient 2. And lastly, I need 20 parts of vitamin E, and there's 1 part in ingredient 1 and 4 parts in ingredient 2. And lastly, ingredient 1 costs $3 per kilogram, and ingredient 2 costs $8 per kilogram. So having done all of that, I'm now ready to start writing my constraints. So the first thing I need to do is I need to define my variables. So that was, let X be the number of ingredient 1, and let Y be the amount of ingredient 2. So I've defined my variables. So now it's going to be a case of my constraints. Well, ingredient 1 has 3 parts of vitamin A, and ingredient 2 has 1 part of ingredient B, and I need at least, so greater than or equal to, 18 of ingredient of vitamin A. And then my next one is going to be 2 lots of ingredient 1 plus 1 lot of ingredient 2 must be at least 15. Third one is 1 part of ingredient 1 plus 2 parts of ingredient 2 must be at least 18. And lastly, 1 part of ingredient 1 plus 4 parts of ingredient 2 must be at least equal to 20. So those are my constraints. My objective function, well, that is, it costs $3 per ingredient 1 plus 8 lots of ingredient 2, and that equals my cost. So there's my constraints. So now I'm ready to flick over into Desmos. And here's Desmos ready for me. So now I've got to type in my constraints. Now, let's see if this will work. 3 lots of X problem of using plus one lot of y has got to be less than equal to 18. Really not happy with my less than equal to. Desmos is really not happy about this because I'm trying to use the writing functions, and even then didn't quite work. Okay, so going old school. So that was 3x plus y. And the next one was 2x plus y. And the next one was 1x plus 2y. And the next one is 1x plus 4y. Now suddenly I'm noticing a thing in my situation, because at the moment this area here is able to be part of my objective area. My space is not enclosed this time. It's this big open space, but I've got these values where x could be negative or y could be negative. So I need to say that x must be less than or equal to 1 and y must be less than or equal to 1, and those are implied constraints. So I need to go back to here and say that x needs to be greater than or equal to 0 and y needs to be greater than or equal to 0, and these are implied, because in the situation it doesn't make any sense. Now I'm ready to insert my table, and now I need to find my coordinates. So this coordinate is 0, 18. So 0, 18. This coordinate is 3, 9. This coordinate is 4, 7. This coordinate is 16, 1. And last but no means least, my last coordinate is 20, 0. And now I need to type in my objective function. And remember, my objective function was 3 lots of x1 plus 8 lots of y1. And importantly, I need to minimize my cost. So my smallest amount of cost to get this is when I use 16 of ingredient 1 and 1 of ingredient 2, and it will cost me $56. So I need to finish my situation, and I need to be good about making sure that I write it in the context. So the company should use 16 of ingredient 1 and 1 of ingredient 2 to minimize costs to $56 per kg. And that's the whole problem done. Okay, I hope you could follow all that, and catch you next time.